Good evening, everyone. Am I audible to all? Am I audible? Can anyone confirm? Yeah, thanks, Kavita. And can all of you see my screen? Okay. Yeah, thanks, Kavita. Yeah, today we will discuss about threads. Okay. So in this session we will discuss only about threads and will not touch about concurrency part. Okay. And today will be the last session for core Java. And after this session, tomorrow I will give an exercise, okay, to all of you. Try to do that exercise, and once you are done with that exercise, we'll start advanced Java, okay? So let's get started. Yeah, as you know, today we'll discuss about multi-threaded programming, multi-threading actually, okay? And then last few classes we have done Java that util package. We try to understand the Java util package. Okay. So let us start from what is a thread. Okay. So what is a thread? We'll try to understand what is a thread and what is a process and how they relate with each other. Okay. So in day-to-day life, on a daily basis, we would have seen multiple things, right? We would have used our mobiles, smartphones, tablets, or our computers, or laptops, whatever it is. So all those things, right? If you see, there will be multiple programs running. Say, for example, if you take a system, computer system, you might be doing something in your Word document. You might be editing a Word document. At the same time, you might be listening to some songs, or you might be reading some textbook in your laptop. So what is happening? You are doing a single person is writing something in the notepad or taking down some notes on the notepad or in Word. At the same time, either he or she is listening to songs or they are doing some other task. That means multiple programs are running at the same time, right? That is what is called as inter-process, not inter-process, multi-process. Okay. That is called as multitasking. Who is doing multitasking? Both the person who is typing or taking down some notes, or at the same time he or she is listening to the songs, right? So that is done by a person who is doing it, as well as the system itself is doing multitasking. What is it doing? Whatever you are trying to edit the document, right? It is trying to edit the document. At the same time, it is running a song, whatever you are trying to listen. Okay. So at the same time, it is trying to do things. So this is what is called as multitasking. So in this multitasking, what is being done? Two programs are running at the same time, right? One is your Word program, and another is your music software, okay, which runs your songs, which plays your songs, okay. So this is what is your multitasking, in which individual programs, okay, individual programs are they are the basic unit of executable code. In multitasking, which is the basic unit of executable code? That is any program which is running. Okay, any program, any software for that matter. Okay, so any program that is running is individual single basic unit of executable code. Okay, but how does that relate to these threads? Let us see what is this thread. Okay, thread is also some part of code which gets executed. Okay, so here if you notice, these two are the two programs, that is Word and your music, right? Music software which runs your music, whatever you call it. Okay, they are independent of each other. They are independent of each other. Okay, these programs, Word and your music software, is independent of each other. Okay, so that is important point to remember. And in case of threads, what actually happens is we will talk only about a single program. Okay, we have seen multiple programs throughout this course, and what we have seen is, say for example, you have one particular program which is running. Okay, it has 10 lines of code. Okay, say you're printing I and some other things you are doing. Okay, and say some 5 statements are dependent on each other, but other 3 out of 10 statements, first 5 statements are dependent on each other, and rest 5 statements are not dependent on each other. So there are 10 statements in a program. Okay, 10 statements. These 5 statements, the top one, are assume that they are dependent on each other. Okay, say for example, you take 2 inputs from your keyboard, I is equal to 10, j is equal to 20. Okay, and then you do something. Say for example, you add I plus j, and then you print the result in first 5. Okay, but in second 5 statements, what you do is, say you multiply both the whatever the values that you enter in that you take in I and j. Okay, multiply, or assume like there are another few statements which does your this one your division. Okay, so ideally what has to happen is, as soon as you enter your 2 values I and j, you can go ahead and calculate your addition, you can go ahead and calculate your multiplication, you can go and calculate your division, you can go and do your subtraction. Okay, it need not be dependent on each other, right? Say for example, I need not have to wait till addition is completed so that I can go ahead and do my subtraction. Okay, let me take an example, quick example that will make things easier to understand. Okay, so please give me a couple of minutes, I'll just finish this one. Okay. So here, what am I doing here? I just have declared two integer variables. Okay, these two are my integer variables, int I and j. So here, what am I doing? I'm trying to add two numbers and display it. These two, assume that these two statements. Okay, think about these two statements. Here, I'm doing multiplication and displaying the result. Here, I'm subtracting two things and displaying the result. Okay, so ideally, what exactly is happening? So I have declared two numbers, and once sum is calculated, I am going and multiplying. Okay, and then displaying it. Once multiplication result of multiplication is displayed, then I will come here and I will subtract the two numbers and display the result, subtraction result. So what is happening here? This first sum is calculated, then multiplication, then subtraction is done. Okay, so there is no like the program execution is from sum, multiply, and then division. But if you see, these three operations are not dependent at all. Okay, the only thing they are dependent on is the inputs that we are giving. Okay, so what we can do in order to write this particular program efficiently, or to introduce multi-threading in such scenarios, okay, where you can execute independent operations in a separate path of execution. Okay, so assume a scenario where you can execute this one separately, and this one separately. Okay, so you can achieve this by writing a separate program for for method for sum, writing a separate method for multiplication. Okay, writing a separate method for subtraction, writing a separate method for your whatever the operation that you want to do. But what are we trying to do here? We are trying to execute all these things concurrently, parallelly. We're trying to execute these things parallelly. Okay, so what are we trying to do? We can try to calculate the sum of two numbers, multiplication of two numbers, subtraction of two numbers parallelly. At the same time, I'm doing addition. I can do multiplication. I can do subtraction as well at the same time. Okay, this is very important. That is why we call it as multi-threading or concurrent. Okay, so these individual execution of these statements, right, which happens concurrently, individual execution is called as a thread. I will explain how that is done. Okay, so some of you might already know, but I will explain those things, how to do those things. Okay, so individual, say for example, assume that the moment I take my input, I declare my input. Okay, I initialize my inputs, that is int I and j. I introduce a way in which all these three operations, addition, multiplication, and division, are done concurrently, and we get back the result, and we will print those things, print the results at the same time. Okay, that is what I'm telling, at the same time. Okay, so assume that I can do that one parallelly, all the three operations, addition, subtraction, and multiplication parallelly. So each set of these statements, I have just given two statements here. One is this one, addition. Let me erase it. So this is one set of operation. This is another set. This is third set. Okay, this is one. This is second. This is third. Okay. Assume that I have some 100 lines of code. Assume that I have some 100 lines of code here, 200 lines of code here, and 300 lines of code here. 300 lines of code here, and they are all independent of each other. They are all independent of each other. Okay, they are all independent of each other. So what I can do is I can take out this piece of code, this set of lines, and execute separately, and take this second set of code and execute separately, and this execute separately. Okay, but they're all executing at the same time. They're all executing at the same time. Okay, they're all executing at the same time. So that is what this particular, say for example, I am executing these 100 lines of code separately, right? This becomes one thread. Okay, this separate set of code which executes separately, individually at the same time at which this particular set of code is running becomes second thread. Okay, and this third set of code which is executing at the same time becomes third thread. Okay, third thread. So what exactly is happening? This is one path of execution. This is another path of execution. This is another path of execution. So how can we define a thread? How can we define a thread? A separate path, separate set of statements which is executing independently. Okay. It is executing independently. What exactly is happening? Each and every set of statements, right? They are executing separately. That is what is called our thread. Okay. Each thread, what it does, it defines a separate path of execution. Okay. Path of execution means you have a number of statements which are independent of any other set of statements which gets executed. Those n number of statements get executed separately. Okay, these n number of statements are getting executed separately. Okay, so that is what a thread defines, a separate path of execution. So in case of as we have just discussed, we have two ways of multitasking. One is your multitasking itself, in which multiple programs run concurrently at the same time. Okay, that is your multitasking. And multi-threading, if you have observed, I had only one program. See here, I have only one program here. That is my test program. Okay, in that test program, I have set of code, I have set of statements which can be executed separately. Okay, this is another set of program or another set of statements which can execute separately. This is another set of program which can execute independently of these two things. Okay, so what exactly is happening? In multi-threading, it is a specialized form of multitasking. It is a specialized form of multitasking in which a single program does multiple operations. Single program does multiple operations through different threads. Okay. Single program does multiple operations through individual threads. Okay. So we will have multiple threads. Each thread will be doing or executing its own set of statements, and the program itself will be completed after all the threads completes. That is not necessary actually, but the program which actually spawns the thread can complete before the thread itself completes. Okay, we will see all those examples in this session. Okay, so any doubts? Anyone has any doubts regarding this? What is a thread and what is a multitasking? Okay, thread we can say, yeah, okay, thread is nothing but a set of statements that are executing okay, in simple way, set of statements which are executing independent of any other statements. Okay, they are not dependent on those set of statements are independent of they are not dependent on any other statements. Okay, yeah, thanks Jason, thanks for confirming. And multitasking is related to your programs like your Word or Excel running independently. Okay, and these are all individual processes, not only softwares. You can say programs, they can be independent processes also. Okay, and here multi-threading, a single process. When we say multi-threading, a single process or single program will do multiple operations. Say for example, you have a Word document. Okay, you are editing that Word document. At the same time, you can what you can do is like you can print whatever is there initially. Okay, whatever you have in that particular document, you can start printing it. At the same time, you can start editing it. Okay, the more what you are trying to do, the Word is trying to print. Okay, by dispatching the or whatever that was there earlier, it starts printing. It sends the contents to the printer for printing. At the same time, you are trying to edit it. Word is taking the input from whatever you are typing from your keyboard. Okay, so Word itself is doing two things at the same time. It sends the contents whatever was there in your Word document for printing, as well as it is accepting inputs from you. That is what is your multitasking. A single program doing multiple things. Okay, multiple things. That is what is your multi-threading. So let's move on. So as I just mentioned, multitasking is a specialized form of multi-threading is a specialized form of multitasking in which we consider only one program. Okay, one program will have multiple threads. But in case of multitasking, multiple programs will be there, multiple processes. Or programs. Okay, multiple processes or programs. Okay, so in case of multitasking, the single or the unit of smallest unit of executable code is program or process. In case of multi-threading, it will be a single thread. Okay, it will be a single thread. So why do we use multi-threading? So it makes our CPU utilization efficient. Okay, say for example, so we discuss about idle time. Okay, idle time here. So say I'm trying to read. We have done it in our IO package, right? I'm trying to read a document from one file. I'm trying to read some data from one particular file. Okay, so you have written a particular program and it is trying to read the data from the file. Okay, it is trying to read the data from file, and then whatever it is trying to read, it reads it and then prints whatever you are trying to print it. Okay, so what exactly is happening is your processor is trying to read it and then it is printing it by executing the statements that you have written. Okay, the processor is trying to execute the program, read the data from the file, and then it prints it. Okay, the speed at which we are talking about, the speed. Okay, speed of processor. The speed at which the processor can process the data, that is, the speed at which the processor can process the data which is read from the file which is there in your hard disk, or which can be from the remote or whatever it is. Okay, the speed at which the processor can process the data itself is much faster than the speed at which we are reading the data from the disk or from the network. Okay, the speed at which the processor can process the data is much faster than the speed at which the data is read from the disk. Okay, so what actually is done? What actually is happening here? Okay, so assume that I'm trying to read some 10 bytes of data from one file. Okay, 10 bytes of data from one file. Okay, so CPU is executing one statement which reads the data from here. Okay, so assume that the speed of your processor is in gigahertz. Okay, and the time which it takes to read a particular byte from the disk may be like in megahertz. Okay, the speed with which the CPU can run is in gigahertz, but it is in megahertz when we are trying to read it from our disk. Okay, let us assume this whatever the disk, it is solid state disk or our normal hard disk. Okay, so it is in terms of your megahertz, this is in terms of your gigahertz. Okay, so say for example it takes one megahertz or some time 1 second to read one byte. Okay, but this can do multiple things at the same time. In 1 second it can execute hundreds of statements. Okay, while reading the data from your file, what it does is like it takes 1 second. Okay, but at the same time it can process hundreds of statements. What are we doing here? We are executing one particular statement, but processor can process 100 statements at the same time. Say it takes 1 second to, just I'm giving just rough so that we can understand. I'm just trying to explain it in this way. 1 second to execute a statement to read a byte from a file in your hard disk. Okay, but the actual speed of CPU is in 1 second it can execute 100 statements, 100 such statements, normal statements, not the reading from not the statement which actually reads the data from your hard disk. Okay, 100 such reads it can do. Say for example it will take input from your keyboard or whatever for that matter. Okay, so what is happening here? 100 statements time is taken for one single statement. So assume that it 1/100th of, so it just reads, I mean it just executes this statement for 1/100th of a second, and then for 99th of 100 seconds it will be idle. Okay, it will be idle. It will not be doing anything. It just says it sends out a message, or it executes that statement which reads the data from the hard disk from a file, and then waits till that particular single bit comes to it so that it can process it. Okay, so that it can process it. So what exactly is being done? The CPU keeps waiting till the data is read from the disk and given to it. Okay, that is when it becomes idle. If nothing is running and only program that is running in your system is this one, that is your program. So it will be idle. If you see the like in task manager, if you see here, it will show like it will be idle for some time. Okay, in your task manager. Okay, that is assuming you have only one program that is executing, which you are trying to read from your hard disk. It may not be that visible, but just for our understanding, I'm just explaining it in this way. Okay, so how to utilize the CPU efficiently. Okay, this is done using multi-threading. Okay, assume that you are trying to read the data from a file which takes 1 second. Okay, so in that 1 second, CPU can execute 100 statements. Okay, in just 1 second, CPU can execute 100 such statements. So let the CPU send a signal to read data from this particular file. At the same time, it starts assume that it starts executing like addition, subtraction, multiplication, such operation. So what exactly is we are doing now? So addition takes 2 statements, multiplication takes 2 statements, division takes 2 statements, and subtraction takes 2 statements. Excuse me. Okay, now one statement, when this particular statement is getting executed, these things can kind of like while CPU is waiting on completion of this particular statement to read 1 byte from the disk to CPU, it can execute all these operations, okay, in separate threads. That is when instead of keeping the CPU idle, we are utilizing this CPU time for executing this set of operations as separate threads. So what are we trying to do here? We are trying to make a maximum use of a CPU. Instead of keeping the CPU idle, we are keeping it busy, or we are trying to utilize CPU efficiently. That's it. So another scenario could be, say for example, you have one particular page open, okay, online site or whatever it is, online site, or you are trying to fill something in your form. It is asking for your username, password, whatever it is. Okay, you are trying to kind of like enter your data in this. Okay, and you have a particular button at this at the end of this particular form. Okay, the time, like the time it takes for you to enter the data and finish this particular form, right? That will before you submit this particular button, it takes a lot of time. Okay, and when you are doing these things, you can do n number of other you can ask CPU to or your computer to do n number of other things, right? Instead of keeping, so say for example, you have this only one program where like you are running, and the CPU is not that much utilized until you press this particular button at the end of this particular form. Okay, so the CPU is kept idle. CPU is kept idle till you finish entering your data in this particular form and click on this button. Okay, instead of that, what you can do is you can execute any other program which will be like while entering this particular program, which will be like useful to you, some other things, so that your CPU is utilized properly. Okay, that is what is done using your threading, which makes efficient use of your CPU. Okay, it keeps the CPU idle time minimum. Okay, threads enable you to utilize your CPU time efficiently. Okay, so I just mentioned local file system resources read and written at a much slower pace than they can be processed by the CPU. That's what I just explained it. Okay, so it takes a lot of time to read comparatively or relatively. Okay, lot of time to read a single byte from your hard disk compared to the speed at which it can be processed by CPU, your processor. Okay, so any doubts till now, or anyone has any questions? Please let me know, otherwise we can proceed further. Okay, so this okay, I assume no one has any questions. Okay, so with this multi-threading, we can there are different environments, right? With multi-threading, we have multi-threaded environment. Multi-threaded environment or single-threaded environment. Multi-threaded environment or single-threaded environment. I'll tell you a simple scenario where you can use these kinds of multi-threads. Okay, assume that you are doing you are working on DB migration project. Okay, you are doing a DB migration project. So assume that your current database is your MS SQL server. MS SQL server. Assume that currently you have this is a common scenario. Okay, in IT industry, this is a common scenario. Assume that your current DB is your MS SQL server. Okay, for some reason your senior IT team decides, or for some reason they want to change the DB from SQL server to some other server, maybe NoSQL DB or Oracle DB or some other DB. Okay, depends on the scenario, where exactly or what exactly you want to implement, which benefits the company. Okay, which benefits the company in whichever the way the benefit is. Okay, so they saw some drawbacks in MS SQL server, maybe performance or something related to license issues or whatever it may be. Okay, so you have assume that they found out a cheaper alternative to Microsoft SQL Server, maybe some open source DB, which actually does whatever you can do with your MS SQL Server, Microsoft SQL Server. Okay, so obviously you will go for your open source DB, which could be your MySQL, MySQL Server, not MS SQL. MS is Microsoft, MySQL is Oracle. Okay, so this is open source. So it is cheaper. It can be free for development. They might charge for your production environments and all. Okay, but nominal fee, very cheap compared to your SQL server. So assume that the data that is currently there in your MS SQL server is very, very valuable data. You can't take chances with the data which is there in your current database. Okay, so what exactly needs to be done? IT team decides, the senior IT team decides, okay, let us have both the DBs, the DB1, this particular DB, and this particular DB up and running at the same time. This particular server is running till everything is migrated properly to the new database, which is your MS MySQL, Oracle, or whatever the database. Okay, properly migrated, and they want to see whether whatever the data that we are whatever the operations that we are doing in whatever we are doing currently, the same operations we can do it with in the new database. Okay, let us consider this as the new database and the old database. Okay, we are talking about DB migration. Okay, and multi threading. multi-threading and the DB migration. Okay, so this is your MS SQL, this is your new DB, old DB. Okay, so assume that as I mentioned, both DB should be there till IT decides, okay, everything is working fine and I don't want further, I don't want to continue with this SQL server, because the data in this particular server which is there is very, very important, and whatever the operations or whatever the business rules that you have set, whatever the functionality that is being currently done with the application, right, with the respect to this particular SQL server is working fine with this new DB. So they want to test whether everything is working fine till the IT team is IT team as well as other teams like end users, that is business, everyone is okay with the operation that is being done with the new DB. Okay, in that way, what if something is not working fine with new DB, so that we will have other fallback alternative. Okay, we can fall back to this old DB. Okay, so that is the decision that is taken by your IT team, your management, okay, whoever it is, including your business. Okay, so in such scenarios, what you have to do is, say some data comes to your application. Okay, assume that you are creating a new account. Okay, some end user is creating a new account. Okay, new account in the sense some email account or whatever it is. So like you create your Gmail account or whatever it is, right? So that data, usually what it used to do earlier, it used to go to your old database. Okay, it is to go to your old database. Now what has to be done? It has to go to your new database as well as your old database. Okay, in such scenarios, what you can do is, like, you can try to, as soon as the data comes, you can read the data, like we did it here. Okay, you can read this data. Okay, whatever the data that our user is entering, you can read that particular data. Okay, and then you can take your actions in separate threads. Say for example, I will insert the data in this old database in one thread. Okay, then I can insert, at the same time I can insert the data in new DB in another thread. Okay, hope whatever I'm trying to explain makes sense with respect to the topic which we are discussing now. I'm trying to give a real-time example for multi-threading, where exactly you can use multi-threading. This may not be the this may not be the only situation where you will see using the multi-threading. There may be n number of situations, n number of places where you can use. For example, your smartphones. Okay, smartphones, your whatever it is, smart devices. Okay, you can include smartphones, your tablets, your whatnot, any other things. Okay, so all those, in such scenarios and all, you can use all these multi-threading things. Okay, wherever you can think of one particular this thing. Okay, one particular system which can do multiple things, not exactly system, one particular program, one particular software which can do multiple things, multiple smaller things in terms of threads. Okay, that is what is called as your threading. Okay, so as I just mentioned, threading introduces two environments, which is single thread and then multi-thread. Okay, so single thread, the situation is this one. Okay, this is your single thread situation. So each and every program, I mean, this operation is independent, this operation is independent, this operation is independent. But what exactly is happening? This is executing in a single thread. That is our main thread. Okay, we will see this also. This is our main thread of execution. So our program starts, this main program starts from this particular method. Okay, that is why this will become a single thread of execution. Okay, this becomes single thread of execution, which is executing all these statements sequentially. Okay, but these statements are not dependent on each other. It need not have to be executed sequentially. Okay, but in single threaded model or in single threaded environment, these are executing sequentially one after the other. Okay, one after the other. This is what is your single threaded model, because only one thread is executing, which is our main thread. Okay, we call it as main. We call it as main thread. Okay, but in multi-threaded environment, as I mentioned before, I can introduce some ways in which I can execute this in a separate thread. I can execute these statements in a separate thread. I can execute these statements in a separate thread, and execution happens concurrently. Okay, this is our multi-threaded environment. This is our multi-thread environment. Okay, so let us proceed further. If no one has any questions, so I'll proceed further. Okay. So that is our single-threaded environment and our multi-threaded environment. Okay. Single-threaded environment, each task, like each statements or tasks are not dependent. They are dependent on like one after the other. Tasks are executed one after the other. In multi-thread environment, they are executed concurrently. Okay. So thread, we know it's a separate path of execution. It's a separate path of execution, similar to our main thread here. Similar to our main thread here. Okay. Similar to this one, like when you start running the program, it enters your main method, which becomes main thread. Okay, which becomes main thread. So similarly, we can write some methods, which we will see in a few minutes, that execute separately from your main method. Okay, which is actually spawned or invoked by your main method itself. Okay, let us see an example where we can use multi-threading. That will make things easier. Okay. So this is one particular program where we have set of statements, okay, which are executing infinitely, and we will see for this particular what we are trying to do. When this reaches, we will come out of this while loop. Okay, initially we have I is equal to 0 and j is equal to 0, and we have initiated one, or we have one loop which executes indefinitely. Okay, and then we will try to print the values and then change some logic about it. Okay, so we will see. We'll try to execute it. So till this particular point, right, it keeps executing. So it keeps executing, and once this particular value is reached, it comes out of this particular loop. Okay. So what exactly is happening? We are trying to, when we are trying to execute this program, it depends. I mean, it continuously goes in a single thread, and then it tries to print the values. So what am I trying to do here? I'm trying to print values A and B, which is 100 and 300, and once this particular program starts, right, I'm not able to print these two values until this program completes, or this particular operation completes. So we are waiting on this particular, within this particular loop, to execute this set of operations, these two statements, until this loop completes. That is, till this particular value is reached, and we are breaking until we break out of the while loop. Okay, only then we will be able to do this operation, that is printing A and B, A plus B, sum of A plus B. That is what is I just explained in this one. So let us see how that can be achieved in multi-thread environment. Okay, so I'll just explain about how you can create threads, and then I'll try to explain it try to implement the same program with multi-threading. Okay, let us proceed further. Okay, so we know what is a thread. Now it's a separate path of execution, which is nothing but a set of statements executing separately. And concurrently with other threads. Okay, so each thread will have multiple states. Okay, a thread can have ready to run state, like it is ready to like what are we trying to achieve with multi-threading? So we are talking about CPU time, right? Idle CPU time. Okay, so when CPU is busy, some threads might be waiting for the CPU time. What does the CPU do? It executes your statements, right? It executes your statement. So some thread might be waiting for its statement to be executed. So that is when we say a thread is ready to run. Okay, running thread is nothing but a thread which is running, or a set of statements within a particular thread that is getting executed, which is nothing but a process kind of thing, where you tell like when you tell a particular thing is running, or an instance or a process is running, what exactly it is doing? The program is executing its statements. Okay, the process is nothing but a running program in which CPU is executing the statement. Similarly, running thread means set of statements. We're talking about set of statements that are getting executed, right? That is when we say a particular thread is running. Okay, suspending means it is in pause state. Pause means it is, I mean, let's say for example you have you are running some video program, okay, or audio program. You're running some video or audio program, and you want to take a break from some song, and you just pause that particular program. Okay, that is what is your suspending. Suspending is nothing but your pausing. Okay, pausing, and then resume. You restart. You start running that audio program again. Okay, that is your resume. Block. It can be a particular thread which is running. It can be like a blocked when waiting for a particular resource. Blocked in the sense, like say for example, you are trying to read data from particular IO, and it takes, as I just mentioned, it will take the time, more time than the process can execute the data which is read from a particular file. Okay, so that is when it says a particular thread is waiting for data to be read so that it can process the data. Say for example, you have a particular thread which reads the data, and this thread is in block state. Till the data is read and given to it for processing. Okay, that is your blocked state. And terminate, it can be graceful termination, or you can terminate on its you can terminate like what do you say a particular thread completed execution, and then it can terminate, or by some other means you can terminate a particular thread. Okay, that is what is terminating a thread. But important thing is, if a particular thread is sleeping, or if a particular thread is suspended, you can resume that particular thread. Okay, so it is in the, say assume that a particular thread is in suspended state, you can resume it from its suspended thread or blocked thread, but blocked state. Okay, blocked state. But once a particular thread is terminated, okay, once a particular thread is terminated, you can't resume it. Okay, so resuming is nothing but still a set of statements are there for this particular thread to be completed, and it is waiting for CPU time to execute those statements. Okay, that is what is your suspending or blocked state of a particular thread. But when you say resume, like say for example, you have a particular thread with 10 statements, those 10 statements. Okay, you have 10 statements. Okay, so a thread executed 5 statements. 5 statements are there, still there. 5 statements are still there to be executed. Okay, but this particular thread did not get sufficient CPU time so that it can execute other last 5 statements. So what it does is like it keeps waiting till it can get CPU, it can occupy CPU to execute other 5 statements. That is what your suspended and block statement. Terminate means, as I mentioned, it would have executed all 10 statements and it has terminated. Otherwise, by some way, something has happened and it got terminated. Okay, that means in between it got terminated, which cannot be resumed. That is what is called as termination of a terminate state of a particular thread. Okay. Let me know whenever you have any questions. We'll try to clarify that. Okay. Okay. So this threading introduces one more thing that is called as priorities. Okay, thread priorities. Assume that there are n number of threads running. Assume that there are n number of threads running in a particular program. So how do you prioritize which thread to run? How do you prioritize which thread to run? How do you prioritize which thread to run first? How do you prioritize which thread to run first? And then first, second, third, or nth way. Okay. How do you decide that? That is decided using your thread priorities. Okay. So thread priorities, thread priorities are nothing but an integer which is assigned by Java. Okay, which is integer. Integer is the type of the data type which is used to assign priorities to the threads, each and every thread. Okay, that priority is used by the dispatcher, thread dispatcher. We call it as thread dispatcher. Thread priority is being used by thread dispatcher to decide when to run a particular thread. Okay, thread priority is being used by thread dispatcher to decide when to run a particular thread. That is here. It is like as it is mentioned here. Okay, sorry. As I mentioned here, it is used to decide when to switch from one running thread to the next thread. Say for example, you have two threads, A1, A2, okay, or T1, T2, okay. So this particular thread is running, and this particular thread also wants to run now. Okay, so how does the dispatcher decides? Thread dispatcher decides when to run thread 2 and when to run thread 1. Okay, that is what is being used. That is what is being done by using thread priorities. Okay, so this is what is called as context switch. Okay, thread context switch. So when a particular thread is running, there will be a number of things that that will be taken care. That will be kind of like taken care when thread is running. Say for example, it might be having some set of variables which is being used for some operations within the particular thread. Okay, when this when the context is switched from T1 to T2, all these things should be kept in some place, right, in your RAM. In your RAM or in your wherever it is stack or whatever it is. Okay, so that is what is called as context switching. It has to save all the data in respective memory and then start this particular thread. Okay, that is what is called as context switch. Okay, this is costly in terms of processes, that is multitasking. Okay, costly in terms of multitasking because so many things. It is multitasking deals with processes which are heavy in terms of memory usage and in terms of whatever the variables or whatever internal things that it is using, right? It is very heavy compared to your normal thread. But in case of as compared to your normal threads, but still there will be something which needs to be saved before one particular running thread switches to other particular running thread. Okay, that is what is called as a thread context switch. So there are certain rules associated with this thread context switch. Let us see how that thread context switch happens. Switch happens when multiple threads are running. So first one, there are two types. The first one is running thread can voluntarily relinquish the control. Control is nothing but giving up CPU. Okay, say for example, thread T1 is running, okay, and T2 is waiting for CPU to run. In the sense, CPU is busy running T1. CPU is running thread T1, busy in running T1, okay, but T2 is ready to run. Okay, now T1 can decide whether to give CPU to T2. Okay, that is what is called as voluntarily relinquishing control. Voluntarily relinquishing control. Okay, relinquishing control. So one thread can voluntarily giving opportunity to other thread to run or take control of CPU to run its statements. Okay, that is what is your voluntarily relinquishing. Another way is a thread can be preempted by a higher thread. A running thread can be preempted by a higher thread, higher priority thread. Okay, say for example, T1 is lower priority thread, okay, and T2 is higher priority thread, and assume that T1 is running without giving up time to T2, means without giving CPU time to T2, In that case, what T2 can do is, T2 has higher priority, right? T2 has higher priority. So what T2 can do is, it can force T1 to give control of CPU so that this can execute. So that T2 can execute first and then T1 can execute, because T2's priority is high and T1's priority is low compared to T2. Okay, so that is what is called as preemptive. Give me a second here. Yeah, preemptive execution. Okay, that is what is called as preemptive execution. In this case, a higher priority thread can preempt lower priority thread to get control of CPU time. Okay, to get control of CPU time. So let us see what is this synchronization. Okay, so we have seen multiple threads are running. Please let me know if you have any confusions or if you have any doubts regarding whatever the topics that we discussed till now. Okay, please let me know if you have any questions regarding the topics till we discussed now. Okay, I'll try to explain it, otherwise we'll move on to synchronization. Okay, I assume there are no questions. I'll move on to synchronization. So okay, so assume that not assuming, we are discussing about threads only, right? So there are n number of threads, T1, T2 up to Tn threads are running in a particular program. Okay, so there is a particular shared resource. There is a particular shared resource. It could be your file. Okay, it could be your database table. It could be your global variable, whatnot. Okay, it could be anything which is shared. Shared among what? Shared among these threads. Shared among these threads. Okay, for example, let us take a simple example. We have, let us say, take a simple example. We have n t1 up to tn threads. Okay, and then we have one simple instance variable or static instance variable. Okay, static instance variable or global variable, which can be accessed by all these threads. Okay, at any given time, it can be accessed by any of these threads. Okay, which can be accessed by any of these threads. Say for example, T1 is reading this particular global variable. Okay, T1 is reading this global variable. Assume the value of this global variable is assume that it is a string. Okay, A, B, C, whatever it is. Okay, so it is reading this one and some other thread. Okay, some other thread, say some other thread, assume that T2 tries to modify the same variable. Okay, modify the same variable at the same time. Assume that, not assume, we know that threads run in parallel, right? Threads run concurrently. Threads run concurrently, right? So this is a very much, this is very possible scenario, very much possible. Okay, when one thread is running and trying to access this value, whatever the value, global variable value, at the same time other thread can come and change this value. Okay, which is not desired by this particular thread. What it is expecting? Say for example, it is expecting some value, hello world. Okay, it is expecting hello world, but in between, when T1 is reading hello world, T2 comes and changes it to hello planet. Okay, T2 tries to change it to hello planet. So when T1 reads this variable completely, instead of hello world, it became hello planet. Okay, which was not the actual thing, which the behavior of a particular program was expected, right? So in such scenarios, in case of shared resources, we need a synchronized access to shared resource. We need we need synchronized access to shared resource, so that the threads work normally. So that the threads work normally. Okay, so the thread works normally. So that is what is achieved using this synchronization method. That is achieved using synchronization in Java. That is achieved using synchronization in Java, which is a concept called monitor. This is very important. Okay, monitor. Okay, that is called as monitor. So what is a monitor? It is just a control mechanism, how to control access to a shared resource. How to control access to a shared resource. How to control access to a shared resource. Okay, that is what is achieved using what is called as a monitor, which is also called as mutex or semaphores. What is this monitor? It is a box. It is a box. Okay, so the concept is like this. Okay, when something enters in this particular box, no one else can use this particular box. Only a person, say for example T1, who gets access to this particular box. Okay, once T1 gets access to this particular box or this particular monitor, others cannot access this monitor. Okay, this particular monitor or a box can be used by only one thread at a time. Only one thread at a time. When one has access to this monitor, others cannot use it at all. Others cannot touch it at all. That is what is a monitor concept is. Okay, how that is achieved in Java? In Java, each and every object, right? Each and every object will have its own monitor associated with it. We will see how that can be achieved using Java. Okay, so each and every object of a particular class will have its own monitor. That particular monitor is entered when an object's synchronization method is called. We will see how synchronized method is defined. Our synchronized method is defined. Okay, each and every object of a particular class will have its own monitor. Okay, will have its own monitor that is entered. Okay, this is very important. That is entered when an object's synchronization method is called. Okay, that is entered when an object's synchronized method is called. Say for example, you have a class A, okay, and it has one synchronized method. It has one synchronized method, okay. And I have this is A class, and I have couple of objects of A. Say for example, A1 is one object, A2 is another object. These two are objects of A class. Okay, assume that in this particular, so you know that this method will be this method exists in both A2 and A1 objects, A1 and A2 objects, right? Assume that for some reason A1 calls the synchronized method. This is an object, it can call its synchronized method. Okay, so when this particular synchronized method is executing, A2 cannot call this, A2 object cannot call the same synchronized method on itself. Please let me know if it is confusing, because I am assuming that whatever I am telling, you people are understanding. Okay, if at all any, if you have any questions, please let me know. Okay, so what is happening? This A1 and A2 are objects of A, and assume that A1 calls synchronized method. It has only one synchronized method. When A1 is executing synchronized method, that means it is executing set of statements within synchronized method. Set of statements within synchronized method. Okay. When A1 is executing some statements in synchronized method, A cannot call synchronized method. That is your same synchronized method. Okay, because once as per this particular statement, we are saying like the moment a particular object calls or enters a synchronized method, it enters a monitor. It enters a monitor. When this object has access to this monitor, which is nothing but, you can assume it as a synchronized method or synchronized statements, okay, which is nothing but synchronized method or synchronized statement. A2 cannot access that particular monitor. So you can consider as this monitor is nothing but a set of statements within your synchronized blocks, synchronized block or synchronized method, synchronized block or synchronized method. Okay, set of statements. You can assume it this way. Monitor corresponds to a synchronized block of statement or synchronized method. So that is when a particular object enters the synchronized method or synchronized block, it enters into a monitor. So once a particular object enters into a monitor, other objects cannot enter into, or other object cannot access that particular monitor, which is nothing but it cannot execute the set of statements which are there inside your synchronized block of code or synchronized methods. That is it. That is I mean, simple way of telling is that one. Okay, when one particular object of a class enters synchronized method or synchronized block of statements, other objects cannot execute the same set of statements defined in your synchronized block or in your synchronized method. Okay, so this is how Java achieves synchronization. This is how Java achieves synchronization. Okay, this is how Java achieves synchronization. So once say for example you have another one more point is, say for example you have class A, synchronized method A, synchronized method B. Okay, it has two methods, two synchronized methods. Okay, assume that one thread enters into this particular synchronized, one particular thread enters this synchronized method. Okay, one object calls or one particular thread enters this particular synchronized method. Other threads cannot access any of the other synchronized methods or blocks. Okay, other synchronized methods or blocks. That is what is mentioned in this particular statement. Okay, not only the same method, any other synchronized method. Okay, this is how synchronization of shared resources achieved in multi-threading in Java. Okay, so let us see how the multi-threading framework itself is designed in Java. Okay, there are two objects. One is your thread class. This is your thread class and runnable interface. Okay, there are two things. One is your thread class, and another one is your runnable interface. Okay, so these two form the basis for your multi-threading in Java. Okay, so a thread class encapsulates a thread of execution, nothing but your thread of execution, nothing but your path of execution, separate path of your execution. Okay, so how can we a new thread? We already have, by default you'll have one thread, that is your main thread. Okay, that is your main thread. Okay, so how can that is created by your JRE, Java Runtime System. In fact, Java Runtime System itself uses multi-threading for doing so many things internally. Okay, when you start a program, it does so many things so that it provides so that a particular program executes properly. Okay, when you run a particular program, be it a simple program or whatever it is, a JRE is invoked, and JRE does so many things so that your program executes properly. Okay, So JRE itself uses multi-threading internally for proper execution of a particular application, program, whatever it is. Okay, so that is created by your main thread is created by, when you run your program, main thread is created by your JRE, your runtime environment. Okay, but apart from that, we also can, as developers, we also can create our own threads. That is the essence of our multi-threading, right? We should be able to create our own thread so that a program does multiple tasks at the same time. Okay, how that can be done? As we just discussed, either thread class or through runnable interface. Either you can extend a thread class or implement a runnable interface. Okay, in case of thread class, you just have to extend the thread class and then override a single method which is called as run method. Okay, run method will be a starting point for a thread, like main method in our any class, any application. Okay, main method is a starting point for executing set of statements, right, for a Java program. Similarly, for a thread, run program will become the starting point of your thread. Okay, in case of thread class, what we have to do? We have to extend the thread class and override run method. Okay, in case of runnable interface, you just have to do implement a runnable interface and then implement runnable interface, provide definition to same run method. Okay, there are multiple methods which are given in thread class. It's get name, get priority, is alive, all those things, join, run, sleep, start, all these things. Okay, multiple methods in thread class, not in runnable interface, which we can make use of when we extend a thread. Okay, so not only just by extending or implementing a particular class or interface and defining run method, the thread will start automatically. So you have to start the thread by using one method called start on a particular thread, start method. Okay, you have to implement or override run method and call start on the particular thread. That is when the thread, that is when a particular thread starts. Okay, so as we just mentioned, we have one thread that needs to be executed in order to spawn other threads. Okay, that thread is called as main thread. So the main thread has its own importance. The two main reasons are like this main thread for kind of like starts or invoke or spawns child threads. That is one reason. And also this main thread does so many things before a particular program completes. Okay, before a particular program completes, it does so many other things like shutting down gracefully. A particular program shuts down gracefully, and so many things it does. So that is why main program is very important. Okay, so the main thread can be controlled using the thread class. We will see all these things in an example. Okay, let us just see how we can create a new thread, and then we will explain all that, and I'll explain with program. I'll explain how to control main thread and all those things. Okay, so the main thread can be controlled using, as we just discussed, thread class. Okay, as I just mentioned, thread will have its own thread class defines its own methods using which we can control the main thread. Okay, main thread is nothing but our main method. Main method constitutes our main thread. Okay. So to get a main thread instance, we can call current thread method. Okay. So when you call current thread method on thread class, which is static method, like this, dot current thread, this gives the reference to the thread in which it is called. Okay, say for example, I am running main method. Okay, that is our main thread, and inside I am calling this statement. Okay, so this will give a reference to the main method itself. Reference to the main method itself. Okay, this will give reference to the main method itself. This will give a reference to the main method itself. Assume that I am calling this thread dot current thread in some thread T1. Okay, in that case, this method will give you the reference to current thread, that is your T1 thread. Okay, so that is what is the functionality of a current thread. You will see how to use that. Creating a thread, as I just mentioned, either implement a runnable interface or extend a thread class. Please let me know what is the difference between implementing a runnable interface and extending a thread class. Okay, just think about it. You'll get the answer. Okay, you'll get the answer. And if you have any questions, let me know. Okay, and implementing a runnable interface. How can we implement a runnable interface? Just create a class that extends that implements a runnable interface, and it must implement run method, which is public void. Signature of run method is public void run. Okay, public void run. So not only just by defining a run method, it won't start. You have to call start method on the runnable instance. Okay, that is one way of creating your thread. Okay, another way is extend your thread class. You can extend the thread class, provide override run method, and call start on that thread. Okay, so how to check whether a particular thread is running or not? Use isAlive method, which returns true or false. It returns true or false. True means the current thread is running. False means the current thread is completed. Current thread has completed its execution and it is terminated. False. Okay. Join means it waits for other threads to complete, so that we can proceed further. Okay. It will wait till the particular thread on which it is called completes. Okay. So thread priorities, the scheduler, as I mentioned, dispatcher or scheduler uses it to determine when to run a particular program. It uses a scheduler or thread dispatcher uses thread priority to give CPU time accordingly. Okay. So how that is defined? It is, as we just mentioned, it is an integer. It is an integer. Okay, it's between 1 to 10. Okay, minimum 1 is minimum and maximum is 10. They are defined as static instance variable within thread class as min priority and max priority. Static because you can use it, because they are static, you can directly call on thread dot max priority and min priority, and norm priority is 5. 5 is a norm priority, which is a default priority for any thread, unless until you change the priority of the thread. That is the default priority which gets assigned to each and every thread that is created. Okay. Okay, that's about thread priority. Synchronization we have seen, which is called as the concept, which is actually using a concept called monitor, which is nothing but called as semaphore or mutex, mutually exclusive object. Okay, mutex. So how that is achieved using in Java? That is achieved using a keyword called synchronized. Okay, using synchronized methods, we can achieve synchronization. So what is the syntax of synchronized methods? Use synchronized keyword. Okay, return type, method name, and then whatever it is, the usual things follow. Access type, synchronized key, return type, method name, parameters, and body of the method. Okay, this is the syntax for. Oh, I have not mentioned syntax. Okay, so that is fine. I'll just mention it here. So your access type, synchronized keyword, then your return type, and then method name, parameter list, and then your method body. Okay, goes here. Parameter list is here. Param list. Okay. Parameter list. This is the syntax for defining synchronized methods. Not only using synchronized methods, we can actually using synchronized block. Okay. This is done using this particular block. Okay. What is the object here? Say, assume that why do we use synchronized statement or synchronized block? Why do you use synchronized blocks? Assume that you are given an object which does not implement any of the synchronized methods. Okay, you are given an object, normal object, which does not implement any of the synchronized methods, and moreover, it is a class which is written by someone else. You can't, you will not have access to the source code, right, to modify certain methods for achieving synchronization. So there should be a mechanism where you can achieve synchronization on object which is not designed for multi-threaded access, multi-thread access. Okay, in such scenarios, what you can do is you can use synchronized keyword and then pass the object on which you want to synchronize. You want that object to be synchronized. The object which needs synchronization is passed as parameter to this synchronized keyword block, and then whatever the statement that needs to be synchronized, that is kept inside this particular set of block. Okay, that is achieved using this synchronized block of code. Okay, so let us see some of the examples how we can achieve that part. Okay. Okay, now we have seen how things can be achieved using multi-threading, how multi-threaded threads can be created and all. Okay, let us see. Okay, so current thread, extending a thread. Let us see an example of extending a thread. Okay, by extending a thread. Okay, so here what we have done, we have extended a thread class itself for this particular class. So what we have done, a thread class defines a constructor which takes a thread, a string, which is where you can specify the name of the thread. Okay, it defines a constructor, not only one constructor. Simple way of defining a thread is it defines a constructor which takes a single string. Okay, it takes a single string as parameter. So in that we can specify the name of the thread. So we have a method getName for getting the name of a particular thread, or setName if the name of the thread is not set. Okay, and we have, as we mentioned, we have to override run method. What it does, it will create five childs. That's it. Okay, child thread. This is not 5 child. It will call this particular statement 5 times, and it will sleep for thread.sleep is a method which takes some long value where you can specify milliseconds for particular thread to sleep. It won't do anything. It will just sleep for a certain time, and then it wakes up and starts executing rest of the program, rest of the statement. For example, you have another statement here, and you have called sleep for 1 second. Here it is millisecond. It is 1 second. Okay, it prints this particular statement. Okay, so assume that you have one more statement here. Okay, so what it does is for 5 times this for loops gets executed. This first time this will get executed, child thread 0, okay, and then it sleeps for 1 second, and then once it is slept, once it has slept for 1 second, it wakes up, okay, it wakes up and executes this particular statement returning from child thread. Okay, that is what this particular thread does. It's a very simple program. Okay, very simple program, and this is our extending thread test. Okay, what are we trying to do? We have created an instance of extending thread. This is our class. Okay, then we have called start method on this particular thread. What happens when we call start on this particular thread? It invokes run method, this particular method. This particular method. When you say start on a particular thread, it calls this run method. Okay, and the thread starts executing. What exactly happens? This is one thread that is executing, and main is another thread which is executing. So 2 threads are actually executing simultaneously. Okay, so let us see how, when we run this program, what exactly happens. Okay, so returning from child thread, returning from main thread. Okay, so child thread is created, main thread, child thread, main thread. So 2 threads are executing parallelly. Okay, after the child thread returns, the main thread is returning. That is, once the child thread completes, the main thread is complete. The main thread is completing. Okay, the execution may not be same all the time. Okay, see, just now we saw first main completed and then child completed just before. So here it completed first child and main, so then main thread. Let us try to execute one more time. Yeah, in this case, main completed first and the child completed next. Okay, that is what is since 2 threads are running, anything can complete first and last. Okay, so this is one way of creating a thread. Another way is implementing threads on a runnable interface. Okay, runnable interface. So what have we done here? It implements a runnable interface and overrides or implements run method. Okay, similar thing only. And here you have created a thread. Okay, create 3 threads, and on each thread call thread.start. So when you do thread.start, it executes run method, which forms the separate path of execution for a particular thread. Okay, you can go through these examples. Okay, not a big deal. So these are all very simple examples. Okay, so I have a couple of more examples which says which uses decides like how a particular high priority thread and low priority threads get executed, and which gives more CPU time, which gets more CPU time. That is, higher priority thread should get more CPU time than lower priority thread. Okay, these 2 are the examples for those things. And to use alive and join methods, I have these two classes. So please go to them. They are very simple. So you should be able to go through them and then understand the program. If you have any questions, please let me know. I'll explain it to you. Okay. And then we have one last topic for today's session, that is inter-thread communication. We have something called as inter-process communication. Okay, wherein multiple processes interact with each other and share the data between them. Okay, share data between them. That we may not see in normal scenarios where we are using products like Microsoft Excel, Microsoft Word, or all those things. There may be scenarios where you want to say, for example, you write some macros in Excel, which imports data from your Excel to your Word document or whatever it is. Okay, that is one kind of inter-process communication. But similarly, we can achieve inter-thread communication. Okay, inter-thread communication is achieved using three important methods. They are wait, notify, and notify all method. Notify all method. Wait, notify all method. Okay. So what does wait does? Wait, when you call this wait method on a particular thread, okay, what it does, this method puts the thread in suspended mode. Okay, puts the thread in suspended mode. So how long this suspended mode will continue? As long as once it is suspended, what happens? A thread is executing means it has a particular it has control of a particular monitor. That means it is using CPU. It is using CPU. Okay. Once it is suspended, it is no longer using CPU, and it allows other thread to use CPU. Okay. So when you call wait on T1, say you call it as T1 dot wait. Okay, T1 goes into sleep mode or suspended mode. Goes on suspended mode. Okay, goes on suspended mode. So what about the other thread? Assume that we have another thread. Now T2 gets CPU time. Okay, we have called wait on T1. Okay, it has gone to suspended mode. Okay, so it will continue to suspend until T2 calls notify method. So it is something like T2 got control of CPU, okay, and when it calls notify, T2 calls, when T2 dot notify is called, it invokes the thread which is suspended by wait method. Okay. Similarly, there may be n number of methods which have called wait method, and they are all sleeping. So we can use, in such scenarios, we can use notify all method. Okay, when a particular thread which is running calls notify all, it invokes all the, it makes other threads which are sleeping by calling wait method. It starts it kind of like it says, okay, who are all sleeping, please get up. Okay, the highest priority thread, in case of a group of threads, the highest priority thread which the thread which has highest priority will start executing or start using the CPU. Okay, when notify all is called. Okay. Okay, so one more thing I just wanted to show you before I complete this session, that is synchronization. Okay, how synchronization is achieved using synchronized blocks or synchronized thread. Okay, so we have three classes here. Okay, we have three classes here. One is caller, okay, call me, and then synchronization test. Here, this particular class is caller, which implements runnable interface. Okay, this is a method. This is a class which actually has one particular method. Okay, so this has this this method has this definition. What is it? It is trying to print this particular string. That is, what is trying to print? What are the message that you give right here while calling this call method? It tries to print the same thing between square brackets. Okay, so caller is the one which implements runnable interface. This is your thread. Okay, it creates thread in this particular constructor, and when you start the thread, it runs this. Okay, run method is called, and then we are calling call method on call me by passing a message. How do we get that message? We get the message as string here. Okay, this message. So ideally, what should happen? What is our expectation? Whatever the message we send here, okay, that should be, say for example, if I send hello, okay, if I send hello, it should be printed as, if I send hello, it should be printed as hello, not W, hello, okay, and then world means it should print like world, okay, how means it should print like how. This is how we are expecting it, okay. But without synchronization, let's see how it gets executed, and let us see how to avoid that, okay. So let us execute this program and see what is the result, okay. So what are we expecting? Hello, world, synchronized. These are the three words which we passed here while calling, okay. Hello, synchronized, world. So what were we expecting? We were expecting hello, synchronized, and world. This is what we were expecting. But what are we getting? Without synchronization, what are we getting? We are getting different results every time when we run this program, okay. Every time when we run this program, we are getting different results, okay. How to control this? We have to provide what is the method which is being called by call me, run method. Here we are calling, right? So what is the method? Call is the method which is being called by multiple threads or a thread which is running separately, okay. So that is why we have to synchronize this particular call method, okay. When we put synchronize keyword with this call method, everything will work as expected, okay. So you can see we have given some delay, that is why it is taking. First it will print open square bracket hello, and then it prints the closing the square bracket, okay. Every time, even if you run it 100 times, it will print the same way, okay. Okay, so here if you notice, when I run this program, even if I run 1000 times also, threads complete first and then main program completes, okay. Thread program completes first and then main program completes. That is achieved using your join method. As I mentioned, join will wait till the thread on which the join method is called completes, okay. So that is why when we call these methods, it will wait till the particular program completes, and then only it will complete main method, okay. Otherwise, we always want to make sure that the main method completes last, because it provides some additional functionality which is required when a particular program completes, okay. So this is an example for synchronization. Please go through that, try to execute it, and let me know if you have any questions, okay. Let us go to inter-thread communication part. So inter-thread communication is achieved, as I mentioned, wait, notify all, okay. So let us see how, let us see an example and how that results, okay. So let me explain the scenario and let us see how that results, okay. So this is how a messaging in Java works. Messaging in Java, okay. Assume that there will be a, this is the scenario, okay? Messaging means you will have a particular queue, okay? And you will have producers and then n number of subscribers subscribe to this particular queue. Subscriber 1, subscriber 2, subscriber 3. Okay? One producer will be there who produces something which can be accessed by these subscribers or consumers. Okay? Consumers. This is your this is called as JNS. It is a simple program, but JNS is actually implemented with this particular concept in mind. Okay? Producers and consumers. You might have heard about TIBCO, you might have heard about ActiveMQ, you might have heard about MSMQ, you might have heard about IBM's MQ infrastructure itself, you might have heard about RabbitMQ. Okay? Which is nothing but messaging queues. Messaging queues. So what it does is, producers produce some data to this particular queue. N number of subscribers will be waiting for this particular message to process. Okay? If this producer produces some message, the subscribers consume this message or consumers consume this message. Whatever the message is there, that is being consumed by subscribers or consumers and processes that message. Okay, it can be data from whatever it is, XML file, your JSON file, whatever it is. Okay, they will have some particular ways, right? So some data you process the data and then put it in somewhere understandable by the application or whatever it is. Okay, so that is what we are trying to simulate it here. So Q is represented by simple Q. What it does, it has one instance variable which is an integer. So get means it provides an interface through which a subscriber or consumer can get a value that is put inside Q, that is represented by integer. Okay. Put is used by producer to put a particular value inside your Q. Okay. So producer is represented by this. So notice that we have two synchronized methods here. Okay, two synchronized methods here. So producer is here we are creating one thread. It implements runnable. Okay, and then inside run method, what are we doing? We are trying to within a particular loop. We are trying to put values using q.put. This is nothing but output. Okay, and then in consumer, what are we trying to do? This is also implements runnable. We have q here. Forget about this particular proper queue, okay? And we have run method which gets the value from the same queue, okay? So in inter-thread communication test, we create one particular queue. Note that we have one queue to which are passed as parameters to these two constructors, the same queue, okay? So what exactly is happening? This particular producer puts some value inside this particular queue, which is represented by Q class. This consumer tries to read the value inside that particular queue using q.get. Producer puts it is q.put, like we have seen here. Okay. So let us try to run this and see what exactly happens. Okay. So here, initially what happened? Putting I in Q, got IQ request, Q got the value. So producer puts 0 inside the Q and consumer gets Q. We have one producer and one consumer. But if you look at here, what is happening? Producer continuously putting values inside the consumer, I mean the Q. But consumer is not able to read at all. So the ideal scenario is whenever a value is put in queue, okay, subscriber or consumer will read the value and process it. So once a value is put in queue, subscriber will get it, process it. Another
put the value, subscriber will again get it, process it, third, put it, process, put, process. Okay, that is how it should be. Once, if I put 1 inside queue, subscriber will get 1, 2 inside queue, subscriber will get 2. But that is not what is happening here. Okay, so say for example 100 times producer is putting values inside queue, but only once in 100 times consumer is getting the value from the queue, which is the last value. If you run this program and carefully observe, you'll understand that. Okay, let us try to correct this problem. Even though we are using synchronized methods, it is not helping us to achieve our goal. So what we can do is, let us try to correct this problem. So how can we correct this problem? We can use wait and notify methods. Okay, so we can use wait and notify method. So proper consumer, proper producer, proper queue, and proper fetch criteria. Okay, so here what have we done? In queue itself, we have wait and notify method. So what are we trying to do? Initially, put means when should we put? When the value, when we have to, this method is called by producer to put a value inside your queue. Okay, so once the value is put in queue, we are setting the value variable, queue variable, that is boolean, which is defined here. Okay, instance variable boolean. Once the value is put, this particular thread goes suspended. This particular thread gets suspended, and what we are doing is we are trying to put the value as set to true, and then we are notifying the other thread which went before this particular put method is called. Okay, and then we have get method. Consumer uses this. So value is, when value is not set, it will wait till the value is put inside the queue. Okay, once the value is put inside the queue and notify, this will wake up. This will wake up, and this statements get executed, and it will return the value. So notify will notify the thread which is executing put, which is our producer. Okay, this is how the program gets executed. What exactly happens? So consumer, a producer calls put and then waits. Okay, it got its value. Okay, when it goes to suspended mode, so here next get will be called. It goes to wait until this notify is called. This will be sleeping. Once notify is called, it executes these things and then notifies it. This the thread which is executing get will notify, and then this wakes up. It makes this value set false, notifies it, and this continues. Okay, so this particular mechanism with wait and notify makes sure that whenever a value is put in queue by producer, that is taken by consumer, or that is consumed by consumer. This is what is called as producer and consumer problem, and that is achieved using the threads with wait, notify, and notify all methods. Note that all these methods are final methods. We cannot override these methods. Okay, let us execute this program and see whether we achieve the same, whether we achieve the actual goal. Okay, whenever the goal is, whenever the value is put in queue, consumer should consume that value. Okay, so if you see, so put value got I. Okay, put value got I, or queue value. Okay, put get. So whenever a value is put in queue, the consumer is getting that value. Whenever a value is put, consumer is getting that value. Okay, that is achieved using. Earlier it was not possible. even with synchronized methods. Okay, so with wait and wait notify all, we can achieve this one. Okay, I will end the session at this point. It's more than 2 hours. This concludes the core Java part, and there are other few simple concepts, which is like a suspending, resuming threads, and all those things. Please refer to those things and get back to me if you have any questions. Okay. Yeah, Kavita. Kavita seems to have a question. Yeah, go ahead, Kavita.
I mean, can you show me that program with the
problem? You have a question on wait and notify, Kavita? Do you have any question on wait and notify?
Yeah, I have the.
You can speak, Kavita.
Yeah,
I think I noticed your.
I am able to speak. Are you able to hear?
Hello? Yeah, tell me.
Yeah,
I'm able to hear
you. I have a question regarding producer and consumer, like how it is going from wait to notify, like producer and consumer. I mean, it is
okay
in the code.
Okay. Let me go to Q. Okay. Let us put some statements. Okay. So consumer has to wait on producer. Okay. Okay. When this is done, so when notify is called, it wakes up your consumer. Okay. When notify is called in put, it wakes up your consumer. When notify is called in get, it wakes up producer. Okay. So how does this work is, so wait is there, right? Okay, it will put in suspended state. So how do you wait this particular thread which is suspended? By calling wait method, some other thread, okay, some other thread which is executing, which is currently executing, that is which is using CPU, calls notify method. Okay, did you get it, Kavita? We'll execute that program and now understand it in a better way. Okay, so wait is it is saying, okay, I'm waiting for some time. Whoever is using the CPU, so currently what is happening? A thread is running. Okay, T1, assume a particular thread is running. Okay, T1 is running. We have two threads, T1 and T2. Okay, T1 is using CPU now. Okay, now it goes into, it calls wait method. Okay, it calls wait method. Now T1 is in suspended mode. Okay, now what happens? T2 starts executing. it has CPU. Okay, it completed its execution. T2 completed its execution, and T2 continues to be in suspended mode till T2 calls notify. Okay, when T2 calls notify, this invokes or it wakes up. Okay, it wakes up T1. Okay, when T1 wakes up, it starts executing its statements. It starts using CPU. Okay, till it completes whatever it was executing before when it got suspended. Okay, assume that T1 notifies, and then T1 wait. It is like a loop in the sense like this will give notification to T1, and this will give notification to T2. It calls wait method on at some point. Okay, this calls wait method on some point, so that this uses T1 uses CPU and calls notify. When T1 calls notify, T2 awakes and it starts executing, and this will go into wait state. This will be in wait state until this calls T1 calls notify. Okay, that continues in this particular consumer and producer problem. Okay, let us see that in code. Okay, let us execute and analyze this program. Okay, let us see some examples, and then okay, I have stopped it. Okay, so what exactly happened? Consumer started and producer also started. Okay, got I. Okay, got I means who is calling this? Where is it? Okay, so your get method got I, that means a particular value is put into the queue. Okay, so where is that? Okay, so your consumer started and it got 0, which was put in the queue. Okay, so once it got I, it notifies. It calls notify. Okay, before that, so if we see here, okay, so notify producer, it comes here and it returns the value, which it returns the value which we are printing it. Okay, in this. 1 minute.
Are we incrementing somewhere here? I mean,
1 minute. Kavita, yeah, we are implementing it. Okay, so what are we doing here? So this is a particular queue, right? This is a queue which has integer value here. Okay, which has integer value. We are assigning that value here. Okay, this particular put method is called by your producer. Okay, this method is called by producer. This method, this class. Okay, so what happens here? If you can see here, I have created a queue which I am passing here. Okay, producer is using this queue to put some value inside it. How that is doing? It creates one value I++ and puts it using put method, and it sleeps for 2 seconds. Okay, when this particular thread runs. When will that particular thread run? When you call this constructor. Okay, we are creating new thread, and then we are starting it. This is when this particular run method starts executing. That is when it starts putting values inside your queue. q dot put is I plus plus. Okay, so that is nothing but your this I, your this I. Okay, and next we are starting another thread which is consumer. So this also creates a new thread, and then starts it, and inside this while loop, which is an infinite loop, what we are doing, we are getting that value, q value. Consumer started, q value, get q value, and sleep for 2 seconds. Okay, this continues. But when what exactly happens is, when producer puts a value inside q, once it is done, it waits for some time till the consumer consumes it and then notifies it. Okay, producer puts the value, wait for some time, and then consumer consumes it and notifies producer. The logic is implemented in such way. Okay, notifies producer saying like, okay, I got this value, and then producer starts putting another value and notifies. After putting the value, it notifies consumer saying like, I have put the value inside your queue, now you can take it. Okay, so that is how wait and notify works out. So if you go through this program, right, please go through this program and send me an email. Okay, if you have any doubts, right, send me an email. You can, I have put the statements. You can call these things are simple statements or debug statements, whatever it is. You try to execute this program and try to analyze exactly what happens with the output. You'll clearly understand. Okay, so waiting on producer. So it waits for producer till it puts value inside the queue. Once it puts value inside the queue, producer puts value inside the queue, it goes on wait state, and it waits till the consumer consumes it and notifies the producer. Okay, producer will once the consumer notifies producer will produce one more value, puts it in this one, what is that, your queue, and then it goes on wait state. Okay, it goes on wait state. This is how it works. See here. So here from this one, right, let us put this, let us comment this particular part. Okay, currently value is set is get method consumer, whether value is set or not. If it is false, notify producer. It says notify producer to put a value inside queue, and it says notify. That means producer is a thread, consumer is also a thread. Notify producer means producer is waiting for consumer to notify that it consumed the data that it has put in the particular queue. Okay, just go to the program and let me know. I'm trying to explain it in whichever the way it is possible for me to explain it. Okay, so now producer wakes up. Okay, producer wakes up, and here it is waiting. Okay, at this point it is waiting. So here it says this particular thing states notify. It is waiting here, and it starts executing this part. Okay, so who is calling? Yeah.
Yeah, sorry
Go
for
ahead.
interrupting. I mean, first that
No,
boolean
okay.
value was false, right? So it will come to
Correct.
this to the
Hold on,
get.
hold on.
It will.
Hold on. Okay, I got your point where you are getting confused.
Yeah.
Okay.
Okay.
See here. I have created one queue. This is a queue object, correct?
Yeah.
So what is this queue? It has one value defined, one instance variable defined. Okay, one instance variable is defined, which is 0 now, integer, which is 0 now as of now. Okay, let me take then. Okay, now what I have done? Sorry. Now what I have done? I have created a producer object here, passed this queue. Okay, and then I have created consumer and passed this queue as argument 8. So now what happens? This is a queue. Producer is connected to this queue through this queue object, and consumer is also connected to queue through this queue object. Okay, inside this consumer and producer constructors, what is happening? Notice. Sorry. what is happening here? Whatever the queue that I passed, I assigned it to this particular queue, and then a new thread is created. Okay, and then start. Okay, what exactly is done at this particular point? It calls run method. Okay, it calls run method. It executes this particular statement. It initializes I to 0. Okay, it enters this loop and puts a value. Okay, since it is I plus plus, it will be value available. Value of I is 0 here. Okay, value of I is 0, and it goes to sleep. Okay, means it goes to sleep for some 2 seconds. Okay, now once that is done, here it is sleeping. Okay, after this is done, here I am creating a consumer object. Consumer will get started. Okay, consumer will get started. It creates this thread. Okay, it creates this thread. It starts running here. Okay, consumer started inside the loop. Does it have? Notice this call to get method. Okay, and producer. Notice this call. Okay, put means it calls put method, right? Let us go to that put method. Okay, initially it calls put method. Sorry. It calls put method. Okay, so put method, whatever the value I have put, that int value, initially it will be 0. It comes here. It checks whether value is set or not. No, value is not set because value is false as of now. It won't go here. Okay, now this value is assigned. We are making this value as true. Put the value. System.put I. We are telling put I, and then notify consumer noticed. Okay, because we have assigned the value of Q to I, which we got it from here. Okay, put means we are assigning the value of I inside Q, which we got it from producer.
Okay.
Did you get it?
Yeah.
Okay, so once this is assigned, that means we have put the value in Q, which we got it from producer, and we notify consumer now. Okay, now at the same time, what happened to our consumer? It called this. It is calling get now. Okay, let us go to get method. Okay, so now I am in get method. Whether value is set or not, no. If it is false, inversion of false is true, so it goes inside this one. So it says waiting on producer, wait. Okay, but here we have made it as true, right? Once the value is set, we made this value as true. So it enters. It won't enter this point at all. It comes here till this value set is false. Okay, then it I think I am not printing that value, so I think I should have uncommented this part. So notify, it goes again here. Okay, so that is how it continues, how notify wait works. Notify and wait used for synchronizing the data producing and data consuming. Okay, so hope you got the answer. If you have any questions, let me know. I'll try to explain it once more. Did you get it?
Yeah, I got it.
Oh.
I was getting confused with this Boolean only value set.
Okay. Yeah, this is one important thing you see here. So whenever you have such confusions, right, you can just control, you might be knowing it, control and enter, you will go to that particular method or that particular constructor. Okay. Then when you call start, it will call on thread itself. But if you know, right, when you call this start, it goes to run method. Okay, and then it puts the value. So you have to control it. This is how you debug issue in your production environment. Not exactly production environment, your development environment or whatever it is. Okay, you have to go through the flow of. You have to understand the flow first. So how the application flow works for one particular functionality. Okay, so then you will be able to easily understand what exactly is happening in that particular application. Okay, so these are all things like, okay, so producer is called and I'm starting it, it comes here and then it is calling put. So what exactly is happening in put? Value, whether value is set or not, we have to consider that boolean value and then waiting on wait. Okay, whether value is set or not, just check. If it is set, wait. Otherwise, it puts the value inside the queue. The value is set to true, and then it is putting and notifying. Okay, so that is how it works. Hope it is. Hope it made it clarified your doubt.
Yeah.
Okay. Thanks, Rita. Sure. Anyone else has any doubt regarding this interpreted communication? Okay. Looks like everyone is fine. So let us wind up this session. It's been more than 2 hours 20 minutes, I guess. Let us wind up this session and please go through everything. I'll try to give an exercise tomorrow. Okay, try to complete it as soon as possible so that we can start the advanced Java. Okay, I'll try to give that. I'll compile everything and give it to you by tomorrow EOD so that you can start from tomorrow end of time, maybe in the evening or something. I'll send out an email, okay, to everyone, or either myself or Yuvraj will send out an email, okay, to all of you, okay, so that you can start working on that on mini project, mini or whatever you call it. Just try to implement it using core Java concepts itself, okay, and then try to see whichever all the concepts that we discussed so far. Try to implement all those things and try to implement in your own way, whichever the way you think. Try to implement it. Let us see, okay. Yeah, thanks everyone. Okay. Thanks for attending. Yeah, enjoy. Good night to all. Bye bye.